Hello and welcome back. Today we're going to be discussing the topic of parking brakes, the different types of parking brakes there are, different ways that manufacturers design them to operate, what the job of the parking brake is, and understand how to troubleshoot different things that can happen with parking brakes and their operation. Most vehicles have a mechanical parking brake. So aside from the hydraulic system, the parking brake is designed to allow the driver to apply the brake on the vehicle and keep it in a position on a 20% grade, fully loaded to GVWR, the gross vehicle weight rating on the door placard, on a 20% grade uphill or downhill. Vehicles have parking brakes on the rear wheels, and they can either be operated with the hand lever, a foot lever, or they could be electronically applied with a switch or a button on the dash. Either way, the parking brake is a mechanical application to hold the wheels and lock the brakes in place that bypasses the hydraulic system. So imagine complete hydraulic system failure. The parking brake, when the vehicle is stopped, should still hold the vehicle on a 20% grade uphill or downhill. When we were covering drum brakes, you might remember this strut that goes in the middle here, that goes across between one shoe and the other shoe. This is what the parking brake is acting against. There is a lever back here, back behind this shoe. This lever right here. That is connected to a cable on the back side. So on this example, this is that lever. This is the cable running through the bracket assembly. And this is where the cable would go towards the front of the vehicle, towards where the driver operates it from. There would be another cable coming from the other side, and they would join together at an equalizer. And the equalizer's job is to create even tension going back to each rear brake. Proper operation of the parking brake depends on correct adjustment of the drum brakes. So if the parking brake isn't holding, the first thing that needs to be done is adjust the drum brakes to the proper tension on the brakes. And that's done at the star wheel down here. These should automatically adjust. They don't always work perfectly. Some of them don't automatically adjust, but for the most part, drum brakes will automatically adjust to the wearing of the friction material and the wearing of the drum as well. The way the parking brake operates in a drum brake, as the cable is pulled, this lever acts against the opposite side shoe. It's not as graceful as the hydraulic operation, but like I said, this is bypassing the hydraulic operation of it and is going strictly mechanical. So you can see this spring here that's on the strut, and this spring is keeping tension so the strut doesn't rattle when the parking brake is not applied. There's a little bit of play here until it engages. Once it engages, with the drum around here, this wouldn't expand very far. Once this engages, you can see it acting against here on the fulcrum, is pushing back on this shoe, and it's acting on the other shoe through the strut. So the point at which this lever pivots is connected to this shoe. And as we actuate the brakes, you can see the brakes expand. With the self-energizing action of a drum brake, it makes them ideal for parking brakes. With fewer vehicles using drum brakes, this drum brake idea, or the concept of the drum brake, may take place inside the top hat portion of a rotor. I don't currently have a top hat rotor available, but on the example of a brake rotor, the caliper is going to be the main method of slowing down this rotating component. On the inside of a rotor, if the design is to put a drum brake assembly in here, This might mean that the rotor itself is larger in diameter, and this portion, the top hat portion of the rotor, is going to be taller. What that does is allow for this surface in here on a top hat rotor to be a machined smooth surface and act as a drum brake for the parking brake assembly. That drum parking brake assembly is dedicated only to the parking brake. It has nothing to do with the normal function of the disc brakes. Again, it's a mechanical application of another way of applying the brakes, and it has to be mechanical, whether it's through existing use of the drum brakes and the parking brake is integrated into the operation of the drum brakes themselves, or that drum brake assembly may be smaller and dedicated inside the top hat portion of a rotor. So this would have to be taller, and it would have to be large enough, and it would act only as a parking brake. Again, the reason why drums are great for parking brakes is because they have self-energizing action. That rotating drum creates a wedge action against the shoes to where the shoe tries to wedge into the drum and helps to apply a little bit more force because the drum is trying to rotate. So the rotation of the drum is creating more applied force at the friction surfaces. So drum brakes are great for parking brakes. The other option in designing parking brakes is to integrate them into caliper design. Calipers already have a hydraulic function, and in order to give them a mechanical function to serve as the parking brake, it's going to require more development, research, and engineering in order to make that happen. A couple companies have done a few different things. I'll show you a couple common methods that manufacturers use in the parking brakes in calipers. Now these can be applied with a cable mechanically from a foot pedal or a handbrake. They can also be applied electronically. So an electronic motor may create the mechanical function of the parking brake job done at the caliper assembly. So here we have a caliper, and on the back side of the caliper is an actuating arm. This actuating arm is connected to the piston. The way this would be configured is the cable would come into this bracket, and the cable would pass through this coil spring and engage this lever up here. For the sake of demonstration, I'm going to remove the coil spring. And without the coil spring, it'll be a lot easier to show the operation of this. On the actuating arm, as the parking brake is applied, it's going to move this actuating arm, and that spring is going to help move it back to its original position. So to apply the parking brake, the cable pulls on it, the spring pushes it back. So at the piston, watch what the piston does. Actuates. See how it comes out a little bit? There's no fluid in here, but the piston is still coming out of the caliper body assembly to help apply the parking brake. Then it retracts. Look at that, it didn't go back all the way. Do it again. Each time it's depressed, it comes farther and farther out. Unless we had something here to block it and stop it from moving, it would keep moving out. So what's going on inside? This is the actuating arm and piston assembly out of the opposite side caliper for this vehicle application. This has a very steep ramp screw on it that engages the same profile screw on the back side or on the inside of the piston. So this piston, when it's fully retracted, sits in the caliper body. When the arm is actuated, the threads move it out and move it back. Notice these indentations on the face of the piston. They're here for a reason, especially this notch right here. This notch engages a peg on the back side of the pad, on the brake pad, to keep the piston from turning. Because as the lever is turning and there's forces against all this stuff, The piston, being nice, smooth, and round, wants to rotate with the threads. So to keep that from moving, if it were to move and allow to pivot, there would be no application of the brakes themselves. So the parking brakes would be functionless. So in order to keep the piston able to move out and back in, it has to be splined. And that spline is in the form of a peg on the back of the pad that rides inside this little recessed portion of the piston. So when the parking brake is applied, the piston doesn't rotate, but the actuating arm acts on those threads, and those threads help move the piston against the inside pad, and then the outside pad is therefore applied through the slides or the floats of the caliper. Here's a Nissan version of a parking brake integrated caliper. And this is the whole caliper design together. Here's our actuating arm right here. Here's our bleeder screw. And this is where our hydraulic line would come in on the banjo bolt. A little crafty Nissan symbol up top. So what I have is a 1/4 inch thick piece of steel. This is going to be our rotor. So I'm going to go in between the pads. And then viewing from the side, I can move this back and forth across the friction material. As soon as I apply the actuating arm, it stops. Off, on, off, on. So as long as the parking brake is not engaged, as long as either the electric motor operated by the switch releases it, whether it's released from a foot pedal, whether it's released from a hand operated lever, as soon as the driver takes the parking brake off, then the rotor can function, the rotor can move freely in between the friction material until either the brakes are applied or the parking brake is applied again. Both the hydraulic function would work and the mechanical function. This is set up the same way as the last example. With the bracket removed, our slide pins are right here. This is the inside pad for this caliper setup. On the back of the pad, there's a little peg right here. The peg on the back of the pad, on the backing plate of the pad, engages on the face of the piston, and this one has 4, 90 degrees apart from each other, 4 indentations, one of the 4 on the piston face. So when this is in the caliper, it is seated inside of that groove. Once it's held up in place by the bracket, this pad is holding onto that piston. And here you can see the 4 different notches on the piston that engage the pad. Some pads have 2 prongs. Some of them have them side by side. Depending on the application, depends on where you will find the holes, the grooves, the notches, and the pegs on the back side of the brake pads. When we do brake service on the friction material on one of these vehicles, that piston has to be retracted back into the caliper. But it doesn't push back into the caliper the same way that a non-parking brake caliper assembly would move. And I'll show you how to do that. There are a variety of tools that are used to screw the piston back into the caliper body. This is the one that I found that was reasonably priced. This is a Cornwell tool. And it comes with a couple different adapters, actually several different adapters. There's one here for a 3/8 drive ratchet with a couple pegs on the back. But all these pegs fit different profiles. And depending on the type of caliper you have, hopefully your kit can accommodate the brake job so you can move through the brake job and not have to wait for a tool, borrow a tool, buy a tool, or be stuck because you can't move the piston back into the caliper body. Some things that this has is opposing threaded adjusters. So one of these is left-hand thread, this one's standard right-hand thread. This one is left-hand thread. And these will differ depending on how the caliper is designed to allow that piston to screw back in. Some of them have to go clockwise in order for it to retract back in, and others have to go counterclockwise to retract back in. So depending on which way it needs to be rotated depends on whether or not you use the left or the right-hand thread. Then it has this piece. That slips around and provides you with something to push against. Then you have an adjuster nut here to take up any slack. So you can keep constant tension on there so you're not fumbling with the caliper. And again, this is going to be done on the vehicle. So the caliper will still be mounted to the vehicle, at least by the brake hose. And if it's loose on the vehicle, one thing I advise doing is mounting the caliper back onto its bracket, even though the rotor is not on there, because it's just one less thing you have to hold. If you are trying to keep this engaged with the piston, keep this adjusted to where there's tension on this plate against the outside part of the caliper body, rotate it at the same time, holding the caliper on the brake hose. We know the damage that a brake hose can incur, so rather than it just hanging there and flopping around, there's going to be a lot happening. It's best to just mount it back up to the bracket and have something solid to work on without the rotor present, and you can focus on just getting that piston back in. Some are tough, some are not as tough, but each case being different, it's good to find the good ways of setting it up to where you get it done quickly and on the first try and reliably. So let's get the Nissan example piston retracted back into its position. The first thing you need to do is find the correct matching adapter. This is the adapter that fits this caliper piston profile. And you check them like that, and they just have to engage enough of the piston. It doesn't have to be a completely flush mount, but it does have to engage the drive surfaces. So there's that engaged, and this will go on the end of the tool. So the two center holes match up to this. This has a magnet on it, so it holds our adapter piece in place. Now let's set it up on the caliper. I like to get the adapter engaged to the piston and then back the adjuster out. So with that in place, the tool is engaged to the piston. It's ready to be rotated. This is keeping tension on the plate against the outside of the bracket. And then we can start threading this in. Now you may have to continually keep this adjusted. The only time you wouldn't have to is if this thread pitch matched the exact thread pitch inside of the adjustment on the caliper piston. So highly unlikely. So expect to keep fumbling with this while you're rotating it in. And what I usually do is I rotate. Any looseness, I'll adjust out. Rotate some more. Adjust. Always keeping tension on these pegs on the adapter. Makes it easiest. Keep going. Bringing it all the way in. Now don't forget that when the piston is going back into the caliper body, it's going to be displacing fluid. Our bleeder should be open with a bleed tube on it so that fluid can go into a container or a drip pan while that's being retracted back into the caliper body. So let's recall the brake pad. The brake pad has a little nub right down at the bottom of the pad. So the pad sits in the caliper. The caliper's upside down, but this is right side up. So if the caliper body was right side up, this would fit in the caliper body just like this. This peg, or this nub, is at the 6 o'clock position. And this piston has 4 notches around the face of the piston. So we need any one of those notches to be in the 6 o'clock position. If we don't engage the nub on the back of the pad correctly, then the pad will not sit flush against the piston. For example, the brake pad wants to engage the piston right here. But if we don't take the time and pay attention to where these notches are, and we just spin it back in until it stops, put the pads in, throw it together, torque everything to spec, and go. And I have made this mistake, so I'm speaking from experience. And this pad is put on here, and the other pad goes on, and everything goes together. The problem is, not only does it keep that piston from not turning, but we don't have a nice flat surface engaging the back of the pad. Not only that, but it actually angles the pad. So the pad is going to be making contact with the rotor along this edge only. And that will affect braking performance. And it won't be long before there's a concern and the customer comes back saying that ever since that the brakes were done on the vehicle, it hasn't worked properly. So, get that lined up correctly. Get that part lined up correctly so that nub can engage on the pad. Now we have a nice flat mating surface across the face of that piston, and that pad's going to make a nice flush contact with the face of the piston. With the nub engaged into the groove, that's going to keep the piston, the pad itself is going to keep the piston from rotating when the parking brake is applied. So what about this example? There is only one solid detent on this to drive on. The other one had 2, so it was even pressure across 2 pegs rotating it around. If we just had one, it's going to try to walk off at the piston. Not only that, it's a pretty large piston face. So going through our adapters, we arrive at this one. Notice it has a lip around it to help engage the outside of the piston. Gives us some stability. There's where our adapter tool engages this plate or this adapter, and we have the one peg to help drive that piston. That's good to go. It's ready to be pressed back in and screwed back into position. So let's do this one. Get our adapter engaged. It's always easiest to get the adapter on there first. Rotate till it's engaged. And then bring your tool in. And then we can engage the tool. And then adjust the tension on the tool. This is using the left-hand thread attachment. And this one's a little more sensitive with wanting to come out of that, with the adapter plate wanting to come disengaged from the face of the piston. I went ahead and mounted this in the vise because it was a little too much to fumble with on the bench. And I don't even have fluids squirting everywhere, so I got a leg up on the situation already, but it's still a little too much to fumble around with because this wants to come disengage from the piston very easily. So I need to have constant tension on this. Like the other one, I was able to rotate it in a little bit and then work the adjuster back out, keep some tension, and I think that had to do with the depth of the peg and the adapter plate and the depth of the groove in the piston. Gave a little bit more room to work with, rather than this piston, which is really shallow. Piston just like this, it's really shallow on where that engagement is. Not only that, but it's a pretty wide mark to hit, so that adapter plate wants to float around in there. Meanwhile, the lip around the edge of the adapter is just barely engaging around the lip of this one. We only have one drive point on it. The depth of the lip is really shallow. The depth of the hole or the groove in the piston is shallow. It's just a little bit more to work with. And this is where mounting this back up to the caliper mounting bracket would make this a lot easier and save you some time and from speaking too much French while you're working on the vehicle. So what I'm gonna do is use a 7/8 wrench on the adjuster nut and keep tension on that as I rotate the T-screw. I don't have a brake pad for this application, but this is where I would match the pad to the piston and see exactly where it's going to lie. And then when I go back together and put the brake pads onto the bracket, and then I put the caliper body over the pads, everything lines up, because that's the point where you have maybe grease on the back of the pads, or you have a tacky spray or goop on the back of the pad that the manufacturer recommends. You don't want to have anything acting against you at that point when you're going back together and you're going on final assembly and you have the fresh rotor surface and you have the fresh pad friction material, and you don't want to contaminate anything, you don't want to have to clean anything. So at this point, before getting the rotor back here and mount it up, if this is mounted to the caliper bracket, you probably have to remove it so you can get the rotor back on. And then once you have all that put back together, everything should be lined up beforehand. That way when you go back together, it goes together nice and smooth. I'm going to show you a couple examples of applications for the parking brake. And a couple of these are foot operated brake levers. Some of these are foot-operated brake levers. These would be located near the driver so they could reach it easily. This example, this mounting plate right here, would go near the kick panel left of the driver's foot in a left-hand drive vehicle. This pedal says push to release. So the way that this mechanism would work is the pedal would be in the up position, the driver would depress the pedal, and then it would hold there. And then as the pedal was depressed even further to disengage, push to release, it would come back up. This one is stuck. Now notice on this one, it also has a lever here, a little override. This piece here is what's called a vacuum servo. So on the end of this vacuum servo, so there's imagine like a tiny little brake booster in here, and it's a little chamber that seals vacuum. And when a vacuum signal or from a vacuum switch is given to this this port here, that would put a vacuum on that lever. So the vacuum would pull that down, and this is just a mechanical override in case the vacuum function didn't work, and instead of had this through the late 90s, early 2000s, and when you put the vehicle when you take the vehicle out of park and put it into gear and your foot is on the brake, those two to this port and disengage the parking brake automatically. And this is like the one in my 96 Honda Civic. Parking brake lever, usually in the center console next to the driver. Parking brake handle is moved up to put it down. A little upward force on it, push the button, and it goes back down. Now right here is an electrical contact. As the parking brake is up and comes down, when it's down, it opens this electrical contact here. When it goes up, closes the contact. Any ideas? Something about a red brake warning light? Light would be illuminated. Light turns off. Light illuminates. Light turns off. Notifying to the driver that A, there's a problem with the brake system, or B, you put the parking brake handle down and the light turns off and there's no issue with the system. So most of the time, the common operation of the parking brake lever is what is illuminating the red brake warning light. Multiple things can turn that on, like we discussed previously, like the pressure differential switch or the level sensor inside the reservoir. If the light were to stay on after that was depressed, then you have to go looking for something else. My sister-in-law had me work on her, I think it was a 2007 Honda Civic with a handbrake lever. And her red brake light was on, and I checked all this other stuff and nothing was wrong with it. And I was checking the electrical circuit, couldn't find anything wrong. And I found when I held the brake handle and I forced it down, I forced the brake handle down, and when it bottomed out, I saw the light flicker. So what I did was remove the little bezel. There's usually a little cover with fibers or like a rubber flap that opens up as it moves past through the sweep. And I was able to see down in there was a little key. And I used a magnet and I fished the key out, and it turns out it was the key to her mailbox at her apartments. And she said that she had lost it some time ago and she's been looking everywhere for it. So the key was jumping the contacts across the parking brake lever on the parking brake lever switch, and that was illuminating the red brake warning light. Just don't know what you're going to find, and you can't always expect to find the problem with the system that you expect from the text, because vehicles are in all kinds of different environments with all different kinds of people, and you would be surprised what types of stress vehicles go through in their everyday lives with their owners or not their owners. Food is another one. Had a gallon of milk explode in the back of Volkswagen Jetta in the summer. We were waiting for a part, and a jug of milk was in the back seat. Customer came by, picked up all the groceries. The vehicle was there for about a week. Part was ordered. Once the part showed up, we went out to pull the vehicle in, and that gallon of milk, this was in late August, that gallon of milk had gone bad and cooked and exploded just with a rancid milk bomb in the back seat of this car. And we called the customer, said, I'm sorry, we can't stomach working on this vehicle. It has to be cleaned out. She ended up having to get it towed away because you couldn't work on it. It was impossible to be inside that vehicle. Next, I'm going to show you a few different applications of parking brakes on working vehicles. It'll be the usual suspects. My Jeep actually does not have a functioning parking brake. That's a whole different story. Maybe someday. All right, here we are in the 96 Honda Civic. Parking brake lever is up. Key on. Here's our red brake warning light. It's always good practice to step on the brake pedal when you're releasing the parking brake. Put the brake down, the light goes out. We're working correctly. parking brakes are good to use because otherwise the stress is being held on the drivetrain of the vehicle. And if the vehicle is an automatic transmission, there is one parking pawl, one tang of metal on about a 1/4 inch thick piece of steel that's keeping everything from moving. So a lot of times automatics will lurch when you let off the brake and not set the parking brake, and it'll lurch to a point where it'll stop. And that's really bad for the drivetrain. So always apply the parking brake before releasing the actual brake. So the Datsun parking brake is a little different. This one is a pull style. So to engage and disengage this one, you have to pull, twist, and then it goes back down. And then to apply it, pull it out. Key on. Super fancy. This bottom one here is brake. Yeah, so this one is brake. And if we put the parking brake down, light goes out. No problems. Set the brake. Good to park. This is the 2014 Honda CR-V. Right here is our push on, push off, or push to release parking brake lever. It's a foot lever. A handbrake lever has to take under 80 pounds of force to apply and hold the vehicle. And a foot pedal has to be 100 pounds of pressure or less to fully apply and hold the vehicle on a 20% grade. I'll get into a little bit of how to test that operation here in a moment. So, key in, chiming away, key on, got all kinds of systems. And our brake warning light is right here. Push to release, light goes out. Applied. Here we are in the 05 GMC Sierra, and you can see this black handle with the P crossed out and the pedal to the left. The pedal to the left is the parking brake foot pedal, and this black handle here is the release lever, or the release handle. Turn this puppy on. Our parking brake is off right now because we just released it. And there it is. Parking brake is on. Pull the release handle. Goes out. So, a good way to test this. So the vehicle has to hold itself on a 20% grade, loaded to max vehicle weight rating, which I guess on this truck is about 9,500 pounds. So that would be fully loaded or with a trailer or something like that. But testing that is not going to be practical in every situation. Every service center doesn't have a 20% grade ramp to park on and test the operation of the vehicle, parking brake one way, pull off, back it on there, and test it the other way. It's just not practical. So the method that I use for testing this is, if it's on a flat surface, it needs to hold the vehicle in drive and it needs to hold the vehicle in reverse. And that's usually my go-to move for testing to make sure a parking brake is holding. If I put the parking brake on and put it into drive and I get movement, then it's not adjusted correctly. Either the adjustment's out on the cables, the adjustment's out on the brakes themselves. Either way, it's not holding, and that's the test that I use. So I do it both in drive and reverse. If it's on a manual transmission vehicle, I'll just slip the clutch a little bit and almost to start from a stop, but I won't sit there and burn the clutch. That's not good. So it just takes a little bit of force forward and reverse to check. So let's do that real quick. Okay, parking brake on. Shift into, let's go reverse first. And we're gonna look to our left here. Release the brake. No movement. Put the brake on, go into drive, release the brake. Lurch forward a little bit. That's just taking out the slack. This one has top hat drums on the rotors in the rear. So this is holding, holds well, works great. Something else to look out for on vehicles that have parking brakes that are not holding is what type of parking brake they have. I mentioned the top hat assembly that the 05 GMC Sierra has. And it's pretty common on trucks if they have disc brakes in the rear. You may find them on a handful of other vehicles. But if it does have that type, a lot of the time there's enough torque on the engine and powertrain to overpower the parking brake. If that's the case, if the vehicle is driven with a parking brake engaged and it's a top hat style, that's not the normal brakes. That is a supplement brake system in addition to the normal brakes that are functioning on the vehicle from the hydraulic system. If that's the case, then you may have a situation that happens quite frequently, to be honest, where somebody drives with the parking brake engaged. Normally, that's going to wear out your normal brakes. Otherwise, if it's a top hat assembly, it's going to wear out the little drum brake assembly that's inside the top hat of the rotor, while you're still using the normal hydraulic function to actuate the calipers on the disc brakes. If that's the case, it doesn't take very long for those to wear out or to overheat to the point where the friction linings become cracked and unusable. So typically, if a vehicle has been driven with a parking brake engaged, there has likely been some overheating of the brakes, glazing of the surfaces, unneeded wear or unnecessary wear on the friction linings themselves. Then that may be cause for disassemble, inspection, and most of the time those will need to be replaced. At that point, if the parking brake shoes are getting replaced, is the drum surface glazed? Does it have hot spots? Typically those are a little on the small side, and those can't really be machined. So if you have a top hat rotor and a drum parking brake inside that top hat of the rotor, that may need to be replaced. Rotor and drum brake shoes, parking brake shoes. So some things to think about, but that's why we do thorough inspections, so we know everything. And the fewer times we contact the customer, or the fewer times that the service advisor needs to contact the customer to have work approved and order parts and move forward with repairing the vehicle, then that's the best case scenario. It's not the best case scenario if the customer is called because they need parking brake shoes. They approve it. Moving along. Oh, you need rotors. Okay. Call the customer. Okay, yeah. Do the rotors with the parking brake shoes. Keep moving. Oops, forgot to recommend pads. And then what are the calipers like? So you can see how that snowballs, and it's not a very enjoyable experience for the customer. For one, this isn't just some entertainment that they're putting money into. This is their vehicle that they're maintaining, and they're not always happy or excited to put money into vehicle maintenance. It can be expensive, and if somebody doesn't plan to budget for something like that, then it can catch them by surprise, and that's not a fun surprise for the customer. So if they keep getting these unpleasant surprises, that's going to affect their overall perception of the business, of the technicians doing the work, of the service writer that's advising them on what they need to do. And then as a service writer, it's a little frustrating if you're getting incomplete information from the technician, and then you have to keep calling the customer. And in the industry, we call that eating crow. Nobody wants to eat crow. So it all works together in a big loop from the customer to the service writer to the tech, and it's a big cooperation communication loop. So the more that you can establish a good level of trust with the technician between the tech and the service advisor, the customer is going to pick up on that. Things will operate more smoothly, and you're going to have a much easier time working on vehicles. And the vehicles are going to give you enough trouble. The last thing you need is human interaction trouble on top of the vehicle inanimate object trouble. So just a couple things to think about. It'll come up repeatedly as you go through the program, and especially once you get into industry and you have egos flying everywhere and people don't want to share tools. That brings me to another point. You should keep a list as you're building your tools. If you borrow a tool from somebody, from a fellow technician, if you borrow a tool 3 times, you need that tool. So keep a list going, keep a tally on what you borrow. It helps return the tools back to the original owner. Always return the tools back clean or cleaner than you got them. And, help them out. Say thank you. Make sure that you hand it to them. Don't just set it somewhere where you think they're going to find it. Don't go opening their toolbox either. If they let you borrow a tool, hand that tool back to them and say, here you go. Here's me giving you your $500 tool back. Here's me giving your $150 wrench back. I am making eye contact with you and I'm handing it to you. I'm done. So thank you for letting me borrow that. I put a tick mark on my list, and if I need to borrow that again once or twice, I know I need to buy it. So that's a good method to use in industry as you're building your tools and making your tool supply, your tool collection a little more complete and a little more functional. So that narrows down exactly what you're going to be needing and using. It's easy to look through a catalog and say, oh yeah, that'd be cool, I'd like that, that's a nice tool. But reality is, how often do you need it? How often are you going to use it? So it's a good way to track it and a good way to stay honest. And if you are a good tool borrower, it makes it easier for people to lend you a tool if you don't have it, which is kind of nice when it comes down to being in a pinch. Some people in some shops just don't share tools. And I told you about one tool that I don't share, my bearing packer. I don't share it. That one, there's usually a communal one. Somebody else can use it, or they can just buy one from Napa for, I don't know, $25. They're not much. There's some things that you just don't lend out. Other things you're cool with. If somebody burns you, if you lend a tool out and it comes back caked in grease or damaged, they're not getting that tool lent to them again, or they're not getting other tools lent to them. So keep yourself in a nice fluid environment, able to borrow something, be appreciative, be personable about it, and return tools back in really good condition and really clean, especially cleaner than you receive them. Doesn't matter how greasy they may be, give them back nicer. All right, so that's all I got for parking brakes today, and there's a lot more to cover. I say it every time, but there's a lot more to cover when you're actually on it, and there's probably some things that I didn't mention. So as we're working through these systems in person, that's when a lot of the things come up. That's when a lot of questions come up. So until then, this has been Parking Brakes. Catch you on the next one. Bye.